All right, calculus students, here we have the same function, but this time we are going to be building cross sections off of a base. So my base here is the squared function again. So this is the space that we're building from. So again, this is at 4. And so what we have here, these are semicircles. Okay, and then that's my diameter of a semicircle. So we'll go straight up about the same amount. So here's my semicircle. So this is kind of an idea of what so there's my diameter, and then we have a little semicircle there. I guess you have the biggest ones here at the end. Diameter of 4, radius of 2, and it's going to go up to a height of about 2 here, and it's going to look like that. So it's a solid made by those type cross sections. And so what we want to realize is that the area of a cross section of a semicircle is just 1/2 pi r squared. Okay, and then we had to discuss what the radius is. So this distance right from here to here in general, not right at 4, but at any x would be then the square root of x. So the square root of x ends up being my diameter of that semicircle. So the radius is half of that. So my radius that I need to consider is going to be square root of x over 2. So we're going to set up our integral as 1/2 pi, and then take this little square root of x over 2, which is now my radius, and we're going to square this. And we can clean up, this is the integrand basically, and so we could clean that up and say, we could square the 2 on the bottom here, gives me 4, multiply by this 2 and get 8, and so we could write this as pi over 8, and then squaring the x gives me just, squaring the square root of x, squaring the square root of x gives me just x. And then we can just evaluate this, again from 0 to 4. And then when we anti-derive the x, I do get pi over 16 x squared. And we're evaluating this from 0 to 4. And I put 4 in and I get 16. I put 0 in and I get 0. So I get a final answer in this problem of pi cubic units.